friends, welcome back. We're talking today about graphing rational functions, finding the x and y intercepts. We're going to put it all together now. So we've talked about finding our vertical and horizontal asymptote. We've talked about finding the holes. So we're going to go ahead and put all of that together and practice finding these. So here is our first example. So here's your list, and we're talking about specifically finding the x and y intercepts. To find your x-intercept, you set y equal to 0. To find your y-intercept, you set x equal to 0. Okay, so let's put all of this together. The very first thing that you want to do, remember, factor and find your holes. So we have f of x equals, this is a difference of squares, so we have x plus 2, x minus 2, and then downstairs, x. This tells me different signs, so plus and minus, and I have 4 and 2 are factors of 8. I need -4, +2. Okay. So we have a hole here because we have something that we can cancel out. Now, so let's write hole. What would make this guy right here equal 0? Definitely -2. Now let's do our new function, and I like to box it so I don't make a mistake using the old function. You don't have to put parentheses. I don't know why I did that. So this is our new function and the one we will be graphing. If I take this and I say, okay, let's plug in a -2 over -2 minus 4. Now the opposite, we get -4 over -6, which is 2 over 3. So we have a hole at -2, 3. Now our vertical asymptote is going to be, let's write it right here. So our vertical asymptote, we set the denominator of the new one. I made a mistake in an earlier video if you saw that. The new one right here. So vertical asymptote is x minus 4 equals 0. Add 4 to both sides. We get x equals 4. That's our horizontal or vertical asymptote. Our horizontal asks us to compare the exponents, and in this case they are equal, and when that happens we want to divide our coefficients. So y equals 1 divided by 1, which gives us 1. So there's our horizontal asymptote. Okay, now let's find our x and y intercepts. So x and y. So the first thing I'm going to do, I think it's easiest just to set x. Oh, and when I find my x and y intercepts, I think that's a good time to start my xy chart. So what I'm going to do is find, set x equal to 0. Because if I do that, it's fairly easy to look at this and say, okay, 0, 0. So like y equals 0 minus 2 over 0 minus 4. Negative divided by negative is a positive, so this would equal 1/2. So x, so 0, 1/2. Now the other one is we want to set y equal to 0. So we have 0 equals x minus 2 over x minus 4. Now, if I multiply both sides of these, let me shift this up. If I multiply both sides of these, x minus 4, this cancels out, and over here, x minus 4, that just becomes 0. So 0 equals x minus 2. Add 2 to both sides, and we get 2 equals x. So when y is 0, x is 2. I multiplied both sides by the denominator, but if you can remember, really your y-intercept, or I'm sorry, your x-intercept occurs just by dealing with the numerator here. Okay, so before we see this on Desmos, I wanted to show you what this looks like graphed by hand, right? So we're going to take the information that we do have, which is that we have a hole at -2 2/3. So 1, 2, and then up 2/3. So like right about there, I'm going to put a hole. And then we know that we have a vertical asymptote at x equals 4. So 1, 2, 3, 4, just like this, and put a little dashed line indicating my vertical asymptote. And then we have a horizontal asymptote at x equals 1. Okay, the next thing that we know are our intercepts. We go over 0, up 1/2, so about right there, and then over 2, up 0. 1, 2, up 0. Okay, so we can already see that this graph is starting to take shape. For more, this is what the function is. So f of x equals x minus 2. I won't do this for all of them, but I do want to show you that you are going to want to plug and chug if you have to graph this by hand. So in this case, we know that 0, I'm just copying my x and y chart that I've already got started on my other page. So like, for example, I want to go over, this is 4, 5. If I go to 5 here, I want to see what happens. I suspect that it goes up like this. So if I plug in 5, what happens? Now, it's also a good idea to plug in a number between the first whole number and your asymptote. So like this is 4, between 4 and 5 here would be 4.5, right? So 4.5. So what happens when I plug in 5? I get 5 minus 2 over 5 minus 1, or 5 minus 4. That's going to give me the 3 over 1, which is just 3. So over 5 up 3. Now if I do 4.5 minus 2 over 4.5 minus 4, and this is where it's best to use your calculator on this, just so you don't make a simple arithmetic error. So if I get those guys, 2.4 divided by 0.5, I end up with 5. Yeah, just making sure. So this equals 5. So when I plug in 4.5, I get 5. So I've got my other ones here. So I suspect that it's going to be shaping like this. And again, if you wanted to plug and chug some numbers, you could. Now, then I know I go over 5. So this is 4, 5. I go up 1, 2, 3. If I go over 4.5, I go up 5. So sure enough, you can see this is starting to take shape. If I did 6, I bet it's somewhere right around here. So if I did 6, I would have 6 minus 2. I can't tell if this is my glasses or if this is, if it's not focused. Maybe I just can't see. I don't know. 6 minus 2, 6 minus 4. So 4 over 2, which gives me 2. So if I plug in 6, 2. My XY chart's never in order. Don't worry if it's not the end of the world. 4, 5, 6, and then up 1, 2. Oh, see, I was close. So yeah, you can see that this is starting to take shape. So that's how you graph it by hand, is just plugging and chugging once you know all the important things. And the important things are the things we've been talking about. Remember, factor and find your holes, your vertical and horizontal asymptote, and your X and Y intercepts. Okay, so what does that look like graphed, right? Again, you can go out to Desmos, and if you do that, you'll see this landing page here. You hit graphing calculator, and then you plug it in. I've done that for us here, and you'll see, yep, sure enough, that's starting to look just like mine, curving in both of those directions, just like this guy. Phew, didn't make any mistakes. Okay, so let's take a look at our next one. We have this guy. We're going to do the same thing. We want to find all of that information, that relevant information, to be able to successfully graph this. So the first thing that we're going to do is factor. Fortunately, we don't have to factor anything. So since we don't have to factor, that means we aren't canceling anything out. So holes, we got none. Holes, none. Okay, the next step is find your vertical asymptotes. That's set the denominator equal to 0, which means X is just going to equal 0, because you cube root both sides, you would get 0. Horizontal asymptotes asks us to compare those exponents of our leading coefficient here. If it's bigger on bottom, remember, botten eats DC. If it's bigger on bottom, like it is in this case, bigger on bottom, 0, y equals 0. This is our horizontal asymptote. Okay, let's find our X and Y intercepts. And again, I think it's easiest to start my XY chart. And I start by plugging in 0 for X, because if I do that, you'll see I get Y equals 3 times 0 minus 4 over 0. Ooh, over 0 means undefined. So we're going to say undefined, or not available. Like, we just don't have one in that case. So if we've got, now let's set Y equal to 0. So when we do that, we're going to say 0 equals 3x minus 4 over x to the third. Let's multiply both sides by x to the third, because just a reminder, when we're dealing with this, when we're finding our x-intercept and setting y equal to 0, you really only care about the numerator, but that way you can see why, because x to the third times 0 is just 0, and there you go, there's just our numerator. Add 4 to both sides, we get, I'm going to flip it around as well, 3x equals 4, divide both sides by 3, so x equals 4 over 3, and this is one of the cases where it's a good idea to turn it into a mixed number, because 4 over 3 can be a little confusing, but if you say, oh, that's 1 1/3, that's a little bit easier to graph. So 1 1/3. Okay, so we have our X and Y intercepts, we have our vertical and horizontal asymptotes. Again, just like I did before, you would go out and graph those and then start plugging in numbers to find where it would work. And when we do that, let's see what we've got here. Ta-da! This is a weird one, because you see it's got that like little bump there. That you just have to plug and chug and practice graphing these so that you know where those are. But that again shows us our intercepts, where we have over 1 1/3 and then up 0. So over, that's about right here. There we go, 1 1/3 and then up 0. Okay, let's try another one so you can see what these guys look like. All right, this is a fun one. All right, remember, first thing you want to do is factor. Boom, let's do this. X plus 2, x minus 2 upstairs, because that's a difference of squares. Ooh, and we have a polynomial here that we need to factor. So let's do a little side work here. And because it's got 4 terms here, I'm going to try factoring by grouping. So group this, we get x squared, and that gives us x plus 1 minus, I can take out a 4, I get x plus 1. These two things need to be exactly the same, and they are. So I have x squared minus 4 as my first, and x plus 1. I am not done. Always ask yourself, difference of squares. We love sneaking those in. X plus 2, x minus 2, because that guy right there is a difference of squares. X plus 1. Okay, so I have factored this denominator to be x plus 2, x minus 2, x plus 1. Ooh, I actually have 2 wholes here this time. I have this one and this one. So wholes, we have what would make this x plus 2 equal 0? It would be -2. And what would make this equal 0? That would be +2. So let's rewrite our new function. We have, I'll write it over here, f of x equals, upstairs I've canceled everything out. That doesn't mean that I have a 0 there. It means I have a 1 over x plus 1. Okay, so what happens when I plug in a -2 here? So I get equals 1 over -2 plus 1. That's going to give me 1 over -1, which equals -1. So when I plug in a -2, I get a -1. Now what happens when I plug in a +2? I get 2 plus 1. I get 1 over 3. So I have 2 wholes occurring right there. Okay, what else do we need to do? We have to find our vertical asymptotes, and that's where we use, this is where it's important to box this in. You don't use this original one, we want to use our new one. Vertical asymptotes, set your denominator equal to 0. If we did that, we would get x equals -1. Horizontal asymptotes asks us to compare our exponents. Remember, if there's not a variable in the top, you can always add one. If I do this, x to the 0 power, because anything to the 0 power is 1, and I'm allowed to multiply anything by 1, because 1 times 1 would just still be 1. In this case, then, this is to the 1 power, so it means it's bigger on bottom. Let's use our notes here. Bigger on bottom means that it's going to be 0. So my horizontal asymptote is y equals 0. All right, now on to the new stuff that we're learning in this part. It is our XY chart. First thing we want to do is set x equal to 0 to give us our y-intercept. And when we do that, we get 1 over 0. So y equals, let's make it totally complete here. And that gives us 1 over 1, which equals 1. So when x is 0, y is 1. Now, when y is 0, we got 1 over x plus 1. Okay, so I want to multiply both sides by x plus 1. X plus 1. So that gives me 0 equals 1. So when y is 0, we do not have an x-intercept because it would be undefined, right? I shouldn't say undefined. It would just be that we just don't have one. So we have all of this information now, and with that information, we could plug that into a graph and then just start plugging and chugging some numbers to see how that would look. If we plug that into Desmos, you can see that we've got that guy right here, and it looks just like this. And so sure enough, you see that we've got that 0, 1 intercept, and then we don't have an x-intercept. So hopefully that helps clarify everything. If you have any questions, please let your teacher know. Otherwise, great work, and I look forward to seeing you next time.